There we go. New. And this time, yep, we're doing something really different. As you can see in the title, we're doing C++ today. So yep. So in this case, you all know we've been working on really open source stuff. So afterwards, all of you can actually download it and then create your own projects for Hippocratic aims. So here's how you get it. First you go to our website. You go down here, go to Learn, click on it. Go down over here, we have C++ libraries. This means everything you see over here are all in C++ and open source to everyone. So, okay. Oh no, we just got flabbergasted. Bright mode. Okay. Anyway, let's see. So if we just scroll down, we have a README. Of course, it's not included in any of the downloads or whatsoever. So of course, one important thing is, yes, you are allowed to download and use this. It's just use it for Hippocratic aims. That's all we ask. Okay. So as you can see, for now we have two libraries for functions and no words. So for functions, it's just a whole bunch of C++ functions which take care of a lot of annoying routines or stuff whatsoever. But yep, it's still under development. And well, typically saying we can start using it already. And then let's see, the next one is NoWhat's, which is a data structure, which it's a AIM is a generalized data structures like linked lists, stacks, queues, trees, and graphs. Like you'll realize that actually all of these has some similarity and all that stuff. So yeah. By the way, why that was strange. My avatar isn't jumping that much anymore. Oh. There we go. Jumpy, 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 jumpy. Okay, interesting. Oh, okay, so the blue, okay. Well, as you can see, I was using VOD mini. But yeah, whatever. Let's see. Also, Okay, I'm testing my music audio music player thingy, but it seems like it's not working. Huh. Well, not quite sure how to play it. Alright, fine, guess I have to trigger it manually then. Whatever. Okay, so back to this. So, as you can see, the version number is actually based on dates. So when you see a newer date, then you know it's time for you to update the stuff. And then you just click on this thing, then you just download everything. Okay, so today there is one complex function in for functions that I would like to stream on archive today. So we have that. So in this case, I already have Ubuntu opened. Where is it? Up there we go. So there we go. As you can see, we are in a console. Whatever works. So I'll just do code. And then now it should take a while and load. Okay, still loading. And yes, I trust myself. Okay, so we are going to be focusing on four functions. So as you can see, oh lord. Oh wait. Okay, let's see if I can Yep, good, perfect. So if I were to like shrink the whole thing down. Good, perfect. Okay, good. So over here you can see our version number. We have our version number up over here. So it's right there. Now, so as you can see, we have a lot of stuff. Let me go Control K, Control 0. Is it? Huh. Sometimes I do forget, like, what? Oh yeah, there we go. It collapsed everything it can. So that's a shortcut way to do it, which is Control K, Control 0. So yeah, that works. So the thing that we're going to focus on is the experimental stuff, and the thing that we're going to focus on is expression evaluate. So basically the main idea is this function, what will it do is you just like type in a mathematical expression, like for example, and then the moment when you press enter, then it should evaluate this whole thing as a whole. But of course over here, it doesn't work. Like Ubuntu doesn't know what it means, like what is 46. So technically speaking, that function will act as a calculator, and that's what we aim for. All right, so here's a few idea of how this might work. In this case, I'm going to need paint in order to explain it. Also, since we do not need that anymore, we'll just close that. There we go. Good, perfect. Is paint loading? Paint is not loading. There we go. Aha! Okay, there we go. There's Microsoft Paint. It may take a while for it to load. After all I have is a potato laptop. So here's how it might work. But of course, first thing first. There we go. Next layers. Boop, boop, and then we'll use that. Use that. Okay, so here how it works. First, we need to know like what are the allowed operations. In this case, we have plus, minus, multiplication. In this case, we use the asterisk or star, as what most of the people will say. The next thing is a slash for division. The next thing is mod or modular arithmetic. We use the percent sign for that. Some other stuff we have is power, and then of course most importantly parentheses. that is the most important part so far what we have. So, like back in the times when we were like learning arithmetic math, we know that there is a certain operation order. So in this case, normally we remembered it as PEMDAS in this case. So in this case, we look for the parentheses first, so that goes first, and then we look for multiplication, division, and mod, and then addition and subtraction. Well, one thing I forgot would be this thing over here. So first thing first is we will hunt down the parentheses first, and then we deal with the power sign, and then we deal with these multiplicative stuff, and then we deal with these additive stuff. So we just go top to bottom whatsoever. Um, so if we just scroll down over here, and then we just go, let's just figure it out, a really weird expression. Oh wait, how about, okay, so I'm going to take this for example. We all know the quadratic formula, minus b plus or minus. You know what, for now, let's just focus on plus. Square root b squared minus 4ac. Take this whole thing by 2a. So in this case, we will need to like write this in a single line instead. And then also let me play the music. There we go. So in this case, this will become minus b plus square root. Oh, we might add that. Or, Ooh, really good question. How do we even figure it out what square root is? Okay, let's assume that square root is some of the functions. It will be its own function and all the stuff. Or, you know what? Let's generalize that. So f will it be its own stuff? So this one over here will be f. Okay, and then we will have b squared minus 4 a c, and then now it will just take this whole thing divided by 2 times a. There we go. So for example, this is the expression we have. So what we do is, first things first, we will need to like start looking for the unnested parentheses. Well, at this case, we know it's from here to here. This is our very first unnested parentheses. Next one is this one. But in this case, let's just generalize. We will always solve and focus on the leftmost unnested parentheses in this case. So the way that I figured out and how to do it is we start from here. Now we keep on searching until we find a closing parentheses. Then you know, starting over here, if you go left, starting over here, if you go left, it is guaranteed that you can find an opening parentheses, and in between this is an unnested expression. So we have that. So that's the first step, and that's what we have over here. Now, excuse me. Now, come to think of it, there is actually a function that we can use already, which is the find object pause, because, excuse me, what I've done beforehand is we have taken, like, okay, so here's the function. We have the string and then the separate character. Well, in this case, the separate character is going to be a space. So every time when we see a space, we just separate those different chunks into their own little substrings or whatsoever. And then now we store them into a vector. So we have that. Let's see. Okay. So, come to think of it, find object pause actually has a better version of it. So in this case, we can actually fix it. Oh boy, loud music. There we go. Good. So it's over here. Matrix. Aha, find object pause. So in this case, yep. So actually, what we can do is, you know what? I'm going to make an overloading function. So what we can do is we just, ooh, I'm gonna go Control B because we don't need it at this moment. And I wish to open Oh, that's pretty weird. Oh boy, that was really strange. I cannot open this like collapse thing. Hey, Microsoft, you might want to fix that. There we go. Find object pause. There we go. Now that's more like it. No, come to think of it, we can actually just rewrite the whole thing with a fresh mind. So what I'm going to do here is, you know what, I'm just gonna copy the signature and then we just start working on stuff. So I'll just copy this whole thing, Control C. Okay, and then we just go whoop. Now this thing is uncollapsible. Wow. Okay, apparently this thing is really broken right now. There we go. So here we have our vector target. Over here, I would like to say int which is starting position. So yeah. First thing first, we need to know if starting position is wait a second, let me bring some music back up. Okay, so back to this. All right. If starting position, if it's out of bounds, like less than 0, or it's outside in vector, size, starting pause, then we know it can't be done. So we'll just do that. Okay, otherwise continue. So in this case, so in this case, we will just say current index will be starting position. And then we will just say while something okay, in this case I'm going to have a boolean. Let's call this thing job done. For now it's false. So we say, well, job done is false, and do it again. So first thing first is we will check if the current pointed object is the one that we're looking for. So in vector, current index is our target. So if so, wait, we can just say return our current index, or otherwise we'll just decide, like, if our direction is wait, whoa. Okay, if it's L, do this, do that. If it's right. Oh, okay. Start from the left, start from the right. Okay. Yep, I'll change that. So one is starting position, and then another one is search direction. So we have that. So if search direction is that, meaning you're heading to the left. So current index minus minus, else if search, that's something weird. Search direction, it's right. Then we'll go current index plus plus. So we have that. Okay. And it keeps on going, keeps on going. But I should say, we should check like if we are still allowed to move on. So it would say if current index is still bigger than 0, or if current index is still smaller than the size of it. If so, then we're allowed to move on. So meaning I'll just get this thing over here and then just paste it over here. Otherwise, it means that we've reached the end. We haven't found any targets. It's not there. So yeah. So come to think of this, that is redundant. So we don't need that. Okay. So for now, let's focus on let's focus on that small function first, and then we can move on from there. So what we can do is let's just open up this, and then we will go to the test file. This let me go boop. So in this case, let's go for vector, find object position. In this case, we have 2 versions of them. There we go. So in this case, I'm just going to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Whatever will work. Next is the target. In this case, let's just say I'm going to say maybe 2. The next thing is the starting position. So let's just say I start at position number 5. Okay. And then direction, I can go to the left. Oh, of course, what I can do is I'll just copy and paste this thing and do it right instead. I can also do the same stuff, but instead, this time I'm looking for number 7. And then I also want to test some edge cases. In this case, I'll be looking for 0. Over here, I'll be looking for 9. Other side. And in this case, I'm going to be extremely naughty. I'm going to search for 20. Of course, we know it's not in there, so it's not gonna work. And then one thing is this one starts at 0, this one starts at 9. Alright, let's see if this runs. So we'll just pull out our terminal here. It should work. Let's do ls. Everything is right there. Okay. So we just go G++. Standard is C++11 -O. Just run. And it's test CPP. Oh. Ooh. Huh. 66. Oh, yep, that's definitely something. Okay. 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 Let's recompile this thing. And there we go. So the moment when we say just run, segmentation fault. Oh no. Classical segmentation fault. What does it missed? Or I forgot one thing. Yep, that is because I didn't initialize it correctly. Fair. I didn't told it is an int. There we go. Hope it fixed it. Still. Huh. Well, boring debugging is expected. Set it as the starting position. Okay. Well, this is true, whatever. If this is what we're looking for, go back, no problem. Otherwise, if this thing, oh, that thing happens, then do your stuff, otherwise do that. Okay. There we go. Oh, that looks interesting. Take a look at the results. So over here, our very first position is 2, which is correct. This one is -1. because if we start from position number 5 and then we look for 2, nope, it's not there. Same goes over here. We are looking for number 7. We start from 5, we go left, and it's not there. And then we're looking for 7, start from 5, going to the right, and yep, that's at position 7. Next thing is position 0, which is the thing because we're looking for 0. This thing it's number 9, looking for that. Yep. And then once we're looking for the 20, it's not even there. So yeah, perfect. Alright. So this means that this function is ready to be used. So keep in mind, there are 2 versions. There are 2 overloads. Okay? Really different. Okay. Whoop. Now back to this. So with that idea is now we can just simply search the stuff. So what we can say is well, we can actually use for vector. Yep, we have that. Alright, cool. So for vector, and then we say find object pause. In this case, we're looking at strings. Okay. So first thing, what we need is the string segments. So that's our vector. The next thing is our target. And then the thing we're looking for is the end parentheses. Also, let me go to the bigger screen so all of us can see. There we go. Good. Let's see. So next thing, it's our starting position. We start from 0, and then we search it to the right direction. This will give us a number, okay, which is actually pin attention E. So in this case, if we go back to paint, oh boy, why do I have 2 of them? Okay, so if we take a look at this, I have decided to call these 2 pins attention pins. This one is the starting pin, this one is the ending pin. So first step, we just know what's over here. Next, based on what this pin is, we just go to the left until we found our very first opening parentheses. Okay, perfect. So in this case, we just go pin attention. S is for vector. Find object position. String segments. The thing we're looking for is a open parentheses. Our starting position is actually pin attention E. Next is our direction. This time we're looking to the left to it. Alright, we're good to go. So just to make a few notes. Will be the starting position of the unnecessary that parenthesis pin attention will be the ending position of it. Okay, a little bit of documentation won't kill you. Hopefully enough. So now, at least we know what to focus on. Next, we need to like decide what operation to deal with. So okay, so of course over here we have to mention if there are literally no parentheses found, like if pin attention is this, or this, then we definitely know, okay, there's no parentheses, or there could be a syntax error, so we'll see. So in this case, we will say this one will be 0, this one will be string segments size -1. So that will be the thing. If there are no parentheses at all, then the whole expression is the attention span. And as you can see, we have a lot of stuff over here. Wait, no, I think we have a better implementation of stuff. Hang in there. Let me cut this thing. Let me paste it over here. So if we come back over here, whoop. So, function map. No. Find object position. So we have starting position, search direction, and then we have ending position. So meaning, if we were to like hit that position, we'll just stop right there. That's it. So this means like there is a searching scope. It's not like the whole thing. Like you want to crop it actually. So here's one thing. Over here, I just want to like say if the starting position is out of range. And technically speaking, we need the same thing for the ending position as well. So ending position and ending position. There we go. So these are two things. Now, just one funny case would be something like if the starting position and the ending position is like on the wrong side based on the direction, it would also catch that as well. So in this case, we will say if starting position is ending position and in vector starting position is already the target. You know what? Let's do this way. So whoop. What we will do here is we'll just go if, and then we can go if in vector starting position is the thing that we're looking for, which is target. Then we will just say perfect. All right, fine. I'm not gonna be really picky. We'll just say return the thing that we have. Or otherwise, if you want to limit yourself to that just exactly one thing, then just gonna say nope, it does not match. So yeah. Otherwise, if one of them is bigger, and the direction is wrong, like over here, if ending position is bigger and then you're looking to the left, we're just gonna say return this. Searching direction is wrong. And then starting position, ending position, meaning if starting position is on the oh boy, if starting position is on the right hand side instead, but you also look, oh wait, that's confusing. Oh lord. Huh. Boy, we can definitely draw a table for this one. Alright. We can draw a table. for this. Oh lord, that's a really slanted. Well, that's a thick line. Wasn't expecting that. Okay. If start and then end, or end and then start, you go left, you go right. Okay, let's see. If we are starting over here, end is on the right, we go left. Well, that's not gonna work. Okay, only if we're starting over here and then we're going to the left, so that will work. Okay, if we were to be starting over here, then we should go right. Otherwise, that should not work. Okay, so let's compare this. Let's compare this. If start end and then it's left. If start and it's going right. Okay. Searching direction is wrong. Okay. So technically speaking, if you want to like search the whole thing, you just say the vector size of it. Vector size -1. Yep, that will do. So just save this thing over here. Then a lot of these will be just wrong. Yep. Ending position. So that would be oh no. Oh well. Well, that's something to think about. Okay, interesting. Well, at least now we know. Anyway, back over here. So we have that. Alright, back to this. So over here it should be string segment dot size -1. This thing over here should be 0. It should look for the whole thing. So yeah. That looks good. Okay. Okay, now we can start another search again. Hmm. Hmm. Interesting. For now, let's just focus on 3 parts, where pin 1 is like our operation. Is that it? Huh. Okay. Interesting. Okay. So the first thing first is we need to look for this. Like the power sign. So we just have that, huh? Starting position? Ending position. Well, in this case, it should be pin, attention, start, and pin, attention, end. So we have that. So this one will either give us its position, or if the expression does not contain this symbol, then will give us -1, so we know if something doesn't go well. And then there are possibilities that there are others operations which has the same level as this exponent operation, so we just need to like pass them over here as well. Min oh, in this case I'll go max. Yeah, because of its power, then Oh, wait, if that's the case, oh boy. Okay. Go from E to S. And then we will go left. Okay. Or something like, okay, how about this? We will just look for every, positions. So if that's the case, then this one should be, pin, attention, start. Pin, attention, end. There we go. Pin, attention, start. Whoops. Pin, attention, end. Do the same stuff over here. Pin, attention, start. Pin, attention, end. Okay, there we go. Yep, good. That looks good. Okay. Go. Next thing we'll be doing the same stuff as well. So over here we go pin, attention, start. Over here it's pin, attention, end. Doing the same thing again. Attention, S, pin, attention, end. Okay, something's wrong. Yep, comma. There we go. So there are also possibilities such that any one of these would be like -1 or something. So Ooh, interesting. Hmm. Okay. Um. Hmm. Because, like, for example, now what I'm thinking is, let's say in an expression, we have this, but we do not have this. So maybe this will be a number, this will be another number, this one will be -1. Okay. Okay, this might be a little bit stupid, but okay, I'm gonna do it this way. For now, that one goes to 0, because afterwards we can actually generalize it. Because it's not exactly min and max anymore. So what we can do is, okay. If RPR pause mole is lesser than, whoa. Oh boy. Wow. On the surface, this is a simple task for a human. Hmm. Well, it seems like we need tokens now. Or can we avoid that? Because oh boy. Like A divided by B multiplied by C. Like, if this is the expression we get, if I were to like deal with multiplication first, this will be ran first. However, we need this to go first. What if, okay, what if we upgrade the find object position thing again? Like, so what we can do is we'll come up here again. This time, the target we're looking at, this time the target is not by itself. It's a group of them. It's a list of acceptable targets that you're looking for. Not just one single thing. Not anymore. So, ooh. This becomes something interesting now. Okay. So, this technically will need to become, well, thankfully, this thing over here is, before it. Let's just hope that we will not go Stack Overflow over here. So in this case, we can say find object position. In this case, our vector, which is in vector. Okay. And then our target. Wait a second. Wait. Okay. So in this case, our target will be in vector starting pause. And then, no matter which one works, start from the left. Now, if you're telling me target, wait. Okay, there we go. This one, we will be calling it target list. in the target list, we want to see if the current thing can be found, starting from the left. If this thing is bigger than -1, if so, it means, yep, we found it. So we just cut that thing. We will paste it over here. Ooh, that's a little bit of brain scratch over there. Okay. So this one over here, it's almost something like a similar approach. Find object position. In this case, we are looking at if, okay, the allowed list that we're looking into. And then the target, we are looking for if the given thing is in the list. In vector, current index, and then direction, let's go with left. Now if this thing is that, then yep, it looks good to me. There we go, that looks pretty good. Alright, let's hit save. Let's head back down here. Yep, we have asterisked that thing out. Alright, back to this. So, definitely one thing is we'll just go with vector int list A, and then we'll go with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then another one, vector int list B. Let's see, I'm going to say 2, 5, and 7, whatever works. So I am just gonna say callouts or cout this thing, vector, find object position. In this case, we're looking into ints. In this case, the bigger list, and then our accepted list. That is not exactly what we are aiming for. Find object pose. Vector type, vector type. Huh. Well, let's see. Starting position, search direction, ending position. Okay. Let's start from here. Moving to the right hand side. And then we will say list A dot size. Okay, let's go with this. In this case, I'm expecting it to say number 2 because we start from 0 and then we go right. So we have that. Or just copy this thing, paste it. This time we start from list a dot size -1. Forgot this, -1, until we reach 0. This time we go left. Both of them, they should give different answer. One of them is 2, one of them is 7. Hit save. Compile. Oh no. Huh. What in the world? 118. Ending pause. There we go. Hopefully that makes sense. Still? Oh. 120. Oh, there's still more over here, okay. And 122. Wait, this one should be target. Huh. Okay, let's hit save. And then let's hit clear for that one. Okay, and then we'll just say just run. Oh. Huh. That's very unpleasant. It should find this one. Huh. If starting pause stat or vectors. It's outside the range. So probably not there. And then both of them are not same, so it just skips this thing. This thing happens, and then I say search right. So nope. Nope. Well, this thing is true if In the target list, we can find the thing we need. Starting from the left-hand side, if the given position is bigger than -1, then we say we found it. Otherwise, if current index is oh wait, we start from 0. -1. There we go. If this thing is bigger than -1, meaning it can be 0 as well, and this thing is smaller than that, then it means that we can still search for it. There is still room to search for it. Keep on looking. Otherwise, says no. Compile. Run. There we go. Perfect. 2 and 7. Okay. Also, if I just go okay, I just checked the font size, and it seems like this is good enough. Alright, so we just come down over here. So now we're looking for a list of them. Of course, this will not work anymore. One easy thing that we can do is we'll just go, whoop, there we go. Now this vector only has one thing. It's just that. There we go. Now it's happy. Same thing over here. Wait a second. Oh, so with that, oh wow, this is really powerful. Okay. So with that, technically speaking, we can just do that. Yeah. And then over here, for now, we only have one thing in our list, or vector, and which is this thing. Wow. From the end to the S, so that's last. Okay. We can actually do the same thing over here as well. And then we know our direction goes from left to right. So, whoop. And then we'll go this one. There we go. So technically speaking, we do not need these. Wow. And then all we need is this. Wow. So this will definitely give us the leftmost thing it can find. Same thing over here. There we go. And then we do not need this anymore. So take this thing, place it over here. Don't need that anymore. Cut this thing, paste it. Alright, so we have that. Now, oh wait. Yep. This is the stuff that we need to look at. Oh boy. I guess over here we have to like start nesting our stuff a little bit. But let's see. Group 1. There we go. So meaning, okay, you know what? For now, okay. No. What? Operation and operands to work with. So, we can see if OPR plus group 1 is not that, and also then we can know pin 1 is that. Then pin 0 will be pin 1 minus 1. Pin 2 will be pin 1 plus 2. Else if OPR group 2, then we would do the same thing. Do the same thing again for group 3, or otherwise there are no more operations inside the unnested parentheses. So it's still oh boy. Okay, so now this will be a little bit different. Pin 0 will be our attention pin. So pin attention start. Pin 1 will be in this case I'm gonna just go pin 2. Pin attention end, and then we will say pin 1 will be pin 0 plus 1, or the other way around, or you know, assuming if everything is correct given by the user. Okay, know which small part to deal with. Okay, so if string segment pin 0 is a number, or we can just say if this thing is this one, and we know it's a power, then we definitely need to like also I almost forgot, if any of the pins are in danger, if pin is this, or pin 1 is this, and then pin 2 is this, then we will just pull the safety brake just to say, wait, something's wrong, halt. So that's the safety switch. Pull it and then halt the whole loop, and then we're done. In this case, float. You know, maybe let's just return something as a string. Brake safety switch. Brake safety switch. Okay, so we have that. So if this thing is a power, okay. Okay. Out of range. Okay, so in this case, you say it's smaller than 0. Yeah. Or we say pin is 0, string segment. No, it doesn't jump up. Okay. Size. String segments. Is it? Yeah. There we go. Yep. Oh boy, I have to say this is a really long if statement. There we go. So over here we'll just say our things are still in range. Now we're gonna start calculating this stuff. Now start calculating. So in this case, we will have this, and then we can say is calculation result. For now, it's a string. So this case, now you can say this is like experiment, so I actually use string as well. Okay, so we can use that, and yes, we can use string. Alright, good. So we will check if the two operands are numbers in this case. So let's say for string, we can say it's detect, just to see if something is a number. No? Okay, if it's not detect, then let's go with math. And it's a number. In this case, our test subject. So string segments. In this case, pin 0. Over here, we are expecting pin 2. There we go. So we have that. So in this case, we will need to like check if that is 0. If this thing is false, then we will need to like say something like in oh boy. For pin 1, this pin 0 is not a number. Else if, do the same thing for pin 2. Expecting okay, you know what? We just say syntax error. Let's go easy on this for now. And then let's go with that. Syntax error. Okay, so we have that. This. Okay. So this also means that let's just copy this thing. Or this. Okay, then we'll just go with that. There we go. Otherwise, everything works fine. So this means we can start calculating. Float. String. I'll call this colors. So colors is forward math. We have that, right? Yep, forward math. Oh wait. Forward math. In this case, let's have How int? Oh lord. Uh-oh. Uh-oh. Okay. First, we need to interpret them as numbers. So up operand A. In this case, it will be string to int of string segments pin 0. It could be that. It's just afterwards, I want you to turn yourself into an int. The next thing, do the same thing. String segments pin 2. So if any one of you out there want to implement the float version of exponent, feel free to do so. And then when you've done it, tell us, post your stuff on GitHub, and then we will implement it if you want us to do that. And then your name will also be included as well. Base is operand A. Another int is operand B. This will give us an int. However, we want you to be a float. Undefined. Come on, pick it up. There you go. Okay, so call res string will be so the way I can think of is string buffer. Okay, so string stream, we call it buffer for now. So buffer.clear, just to make sure it's clean. And then we can say buffer goes in. What do we need? That is call res float. That thing goes in, and then we say buffer goes into call res float string. There we go. So now string gets it. Now buffer clear. You know what? We can actually make a function to do that. Do we have that? Let's take a look. So this thing has something to do with string and maps. So, okay. Oh. Okay, cool. No one done that yet, so let's do float to string. Because string to float, we already have that, which is STOF. So float to string. Float in float, and then give us a string. So in this case, we will need a string stream, which we will call it buffer. For now, buffer dot clear, and then we can say buffer will accept in float, and then buffer will pass that thing into something. So in this case, we'll just say string and result, and then over here we can just say result. So over here we can just simply return result. So let's just give it a test. So over here, let's go with that. Let's go over here. So over here, let's go with forward, a math part, the string part, is it? Or, oh wait, no, it's a string part, and then the math part of it. So we have float to string, .1 to 5, I don't know, 1 to 5, 1 to 6, Gura, you know I'm referring to you, whatever. So this will give us a string. I'm going to say plus A, B, C, and maybe D, E, F at the front. So over here, I'm going to say cout, this whole thing, and then there we go. Hopefully this thing works. Compiling, there we go. There we go, perfect. It turns it into a string. Nice. Okay, now we can focus on this thing. Okay, so over here. So this means that we can say forward string math float to string. So in this case, we can just say call as float. Excuse me. And then this will be our call as string. There we go. So we don't need this anymore. So yeah, there we have it. So that's the case for power, or else if this whole thing over here is this. Then we all know we need to do multiplication. Well, technically speaking, all of them needs to be that. Oh lord. Hmm. Hmm. Okay. We can actually just copy and paste the whole thing though. We're expecting this to happen. So in this case, they can be float in this case. So float, float, whoop, whoop, and then this time it should be as simple as operand A multiply operand B. And then we'll just turn that thing into a string whatsoever. Soon afterwards we will do the replacement. It's just we need to came up for the answer now. And it seems everything's good. Okay. Otherwise, if this thing is division, do the same thing as well. Otherwise, if it's modulation, then we need to force it as an integer. This thing over here. Take this whole thing, turn it into a float. Yep. So there we go. There we have our power. There we have our multiplication, division, and modulation. So the next thing will be addition. So let me just copy this thing. Whoop, whoop, plus. Expecting this. So in this case, it's almost the same thing. Add them together, lovely. Excuse me. Excuse me. Oh boy. Okay. So this thing. Ooh, interesting. Because sometimes this sign will be also used as the negative sign. But what if we invent a new rule such that so if you want something to be negative, we don't want you to use the minus sign. Instead, we come up with a function for it. So So in this case, the function that we have for now is neg, which means negative values. So in this calculator, you will not write negative numbers by using the negative sign, space, and then the number. So in this case, there are two ways to do it. Either you use the neg function, or you just stick the negative sign on the left side of your number, no space in between. So that whole thing will be interpreted as a number. So that's one way to do it. So in this case, pin 2. Yep, in this case, pin 2 needs to be a number. It doesn't care about what is pin 0. So, yeah, it only cares about pin 2. So, there we go, pin 2. Interpret it as a float. Put it in over here. Multiply it by -1. So that will become a float. Oh, please don't tell me. Operand A. Wow, where's operand A? I don't know. Well, that's definitely taken a while in order to interpret what was going on. Okay. So there we go. That is everything we have so far. Oh Lord. But I would say this feels like a little bit of you know what? I'm going to do it this way. Group 4 is bigger than -1, meaning we have found something. So if that is the case, then hopefully enough that the function, it's just taking one number. So that would be the parentheses. But we are already looking at the attention span. Oh boy. Well, I can only say that is definitely a new thing to look at. Meaning if there were to be a function, then pin 0 will be our function position. For now, pin 1 is pin 0 because based on different stuff. For now, we'll have that. So, pin 0 will be the function head. So if that's the case, then need to move pin 1 to the right. So pin 1 is pin 0 plus 1. Over here, we're taking pin 1 as our operand, A. And then take A multiplied by -1, that will be our thing whatsoever. Okay. Once we have our thing finished, now start replacing string. So I'm going to interpret it this way. So let's just say in this case over here, assume that this is the expression we have, and then we just determine that somehow this one is the thing that we need. Oh wait, whoa, 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 whoa. What if we are now dealing with... Ooh, wait. There are no more operations inside the unnested parentheses. Oh, okay. What if now we're dealing with the parentheses now? So what if 0 is... Wait, 0 plus 2 is pin 2. If so, okay. If so, well, I can only say callRes float will be for string, and then math, and then we will be converting a float to a string. In this case, it would be wait. We can actually just do this, and then we'll just go string segments. Yeah, we'll go with that. So in this case, if we look way up over here, either. Wait. Huh. If the parentheses only contain one number, if this thing happens as the first criterion, next thing is string segments pin 0. That's the inputting part, and then we will need to say, well, it's not an or, we need and. There we go. And string segments pin 2 is a closing parentheses, and also we'll just pull out forward string, the math part of it. Well, we will need to check is number, so that will be that. In this case, it would be string segments pin 1. If all of these is true, then we say no problem. Okay. Otherwise, we just say return emergency halt. Now we're gonna start replacing the string. Okay. Int. Do you have a current index thingy going on? Okay, I don't think so. Good. Okay, so current index. Now, starting from 0. So we'll do this. While current index haven't reached the stuff yet. So when current index is still string segment dot size. Okay. Do the following. Also, we will need to like prepare our new vector. So vector string segments, and it's a new one. So yep, there we go. So if so for example, if our current vector is over here, for now I'll just use the letter O. I'll just copy and paste the whole thing. So if, because we know this is our oh boy. Okay, that is our attention span, I believe. Wait a second, how do we define attention span again? Oh, okay, good. So now pin 0 is always on the left. Hopefully. Okay, pin 0 is always on the left. Wait. Hmm? Sneaky. Okay. Okay. So now if, okay, so this means this is now pin 0. This is pin 1. This is pin 2. This one will be attention start. This one will be attention end. Okay, cool. So if okay. Whoop. And then I go, this is current. So if current index is lesser than P0, then we'll just copy and paste. So in this case, string segment new pushback string segments current index, whatever that is. Okay. So, and then when it's done, current index plus plus, and then do that again. Like as long as it's smaller than P0, just push back whatever it is. Otherwise, else if current index is now pin 0. So now we know we have to start push back the calculated string. So we just paste it over here. This time we'll just push back the string. So call res string. There we go. So this will be 7. Okay. And then in this case, we'll just jump to because in this case, I'm just going to say this, okay? So in this case, attention span should be over here. All right, good, perfect. So in this case, technically speaking, oh yeah, it should jump to attention span. Okay. So current index is now attention span E. And I just keep on doing the same thing. Wait a second. No, it should jump to pin 2 plus 1. Oh lord. Pin 2 plus 1. Yep, it should jump to over there. Pin 2 plus 1. And it starts going on. So as long as it's like, there we go. Current index. Then it keeps on doing this until it goes outside. Then yeah. And then when the whole thing is done, we can say string segments will become string segments new. And then reiterate. Ooh, this is actually really scary though. Where does the while loop end? While over here? Okay, good. Like, if everything goes well, then we're just gonna return string segments, the very first thing we see. So over here we're just gonna say cout before can we like print everything? Array to vector, concat bin, cycle belt, find opt pause, function map, matrix core. No. Okay. Let's do can we do convert? Because I want to print all of them. No. Okay. Huh. So in this case, let's just make a new function again. Or does cout has it? Force print vector. I think we have that. Force print vector. So that's the cout class. Okay. So do we have it here? Yep, yes, we have cout. Good. Wait, does the cout class returns or it's just void? Force print. Oh, it returns a string. Perfect. Nice. Okay. Turns a string. So let's do this. For cout force print vector. In this case, it's the vector, so in this case, it's string segments. I'm going to call it before. Next thing should be for cout force print vector. This time it's the string segments new after there we go. And then over here we will say string enter step buffer. We don't care what it is, it's just I want to like see the iteration to just go through everything so we don't end up with an infinite while loop and then we know we can immediately stop when we see one. So we'll just say cin. Wait, no. Get line from cin into enter step buffer. So there we go. Let's save this thing. And then hopefully this thing works. Now, so for experimental expression evaluate. In this case, one day I just asked my friend to like figure it out. What is like the weirdest expression that he can come up with? And so he come up with this. So shout out to you, John. So in this case, I'll just paste it right here. Uh-oh. No. This case, separate character should be a space. Now, we just need to give this thing enough space. Whoa, this thing is definitely taking up a lot of stuff. Excuse me. So I have to say, this calculator over here will be extremely sensitive to spaces. That's what we have for now. Oh boy. It compiles. Oh. Alright, time to step through everything. Moment of truth. Let's go. Segment. That's the first thing that we run into. Obvious enough. Obvious enough. Okay, okay. So now we have to like start debugging and see where it went wrong. So I'm gonna just say here, 1. In this case, I want to like include an emoji. This may take a while for it to come into play. Oh, there we go. So in this case, it's going to be a flag. Oh, I always use this one for debug purposes. Okay. Just want to make sure that it managed to get inside though. Okay, so it's not there. Definitely not that one. Okay, let's see. C out, forward, string, force. Oh wait, no. It's the C out. Force print vector. In this case, string segments, str scg. Let's see what does it says. So over here we have all the things. So at least it managed to like separate everything correctly. So that's good. And then segmentation fault. Not quite sure where went wrong. Okay. So in this case, I'll just like cut this thing, paste it over here, and then cut this thing. You know what? I'm gonna paste it here. There we go. So it is still there. Okay, so this means that this part has no problem. Okay, let's see. Is it really though? Pin attention S is new line, and then say pin attention end. Pin attention E. Okay, so we're still there. Does it get a starts at number 1, ends at 13? So I would say this will be the very first attention span. So let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect, works like a charm. But still segmentation fault. Okay. So no, there's a problem over here. So if pin that thing is equal to that or equal to that, well, apparently none of them, so this part will not run. So let me cut this thing. Okay. This one can go as well. So now we have that. Aha! Some progress. So now we know it's here somewhere. Well, nothing too funny over here. Well, it can't be those. 2, 3, 4, and 5. Huh. So this one fails. The others are completely fine. Let's take a look why. In our attention span over here, the things we only have are the exponents, the minus, and nothing much else. Exponent and minus. So exponent is over here, minus is over here. There is no multiplication or division or whatsoever. Okay. So that's really odd. Because after all, this one should like return a -1. Start, going to the right, ending at E. Find object, pause. Let's take a look at that. There we go. That's the thing. So in that case, find an object, pause, target list. Oh, If current index, huh? Let's see. Oh Lord! Oh, wow! There is hope. Wow, there is hope. Okay, 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 easy. I'm gonna go Control C and like kill this thing. Okay, that is some progress. That's good. That's good. Okay. So let's just come back down here. So at least now we know we do not need all of these right now. Okay. I'm gonna just cut this thing and then just bring it along with me. So, the first thing, that one is before. I'm going to expect that 5 to the power of 8 is going to be, oh no, that's a huge number. You know what? I'm going to do some proof checking just to make sure that I'm doing things right. Okay, I am currently looking on another machine. Currently, of course, you all can't see it because it's another machine. Wasn't streaming it over there. One thing I can definitely do on that thing is I'll just pull out my calculator. And then we'll just go whoop. Can we go fine, whatever. 5 to the power of 8. 5 to the power, oh lord. Okay. 5 to the power of 8. Yep, I'm right. Yeah, cool. Cool. So, also, force print vector. There we go. Over here, I can say string item left side string item separate and then string item right side. There we go. So this one over here is definitely item separate. So we have that. Outstring vector segment. Over here, I'll definitely say something like item left side, and over here I'll say item right side. So this means that if I come down over here, here we go, item left side. In this case, I'll be saying this. Item separate. For now, I'll just give it a space. This one, item right side, I'll be having that. Same thing over here. Left side, space, right side. Okay. So, alright, let's see if this thing can terminate with a single number. At this point, I don't care like what is like the, you know, because this expression is a weird one, so do not expect good values out of it. There might be overflow or something. So and then I'll just do clear, and then I'll just do just run. Oh no. Okay, I don't know what to look at. The next thing is, yep, it's gonna start doing stuff to that, I believe. Uh-oh. Uh-oh. Mm-mm. Mm-mm. Okay, even if it's just 2 to that power, reasonable. Now we're looking into this. 8 to the 2, so that's 64. Good, perfect. And then okay, we're still looking over here. In this case, oh no. Oh no. That's way too big. That's way too big. Of course it's gonna die. Oh no. That's way too big. But at least now we know over here it ends up a problem. Well, okay, we have to be careful with these numbers. So you have to make sure that these are like small enough. Okay, hopefully that's good enough. Well, to make this thing more readable, I would just say we'll just have that. Okay, so over here it broke. Okay, so first thing first is we definitely need to know like okay, in this case we'll just say we'll start debugging. Int to string. How do we do that? Oh, Nemo, whatever. Sorry didn't catch you there, but well, apparently I'm trying to like make a you know, like you can just like enter a certain math expression and then it just starts calculating and then give us the result. That's what I'm trying to get. Apparently, something's out of range, and then I'm trying to debug and see where did it went. So yeah, we have that. Anyway, how things have been on your side though, whatever. Let's see, for now, let's go see out. Let's go with this, Control X, there we go. For now, this one returns an empty string, or just say error. And then pin 0, pin 0. And then we'll do the same thing. Control C, hop, hop. 1, 2, 1, 2. Alright, let's see where this thing breaks. Huh. Strange. Okay. Huh. I didn't know that it can even reach -2. So, let's see. Well, over here. Should be that one. Let's take a look. Pin 1 is that. Pin 0 should be this -1. Pin 2 should be that. Huh. Okay. Well, at this point you should be helpful when I start debugging stuff. So, pull out the flag again. Up pour pass. G1. Okay. Copy this thing. Paste all the way along. 2, 3, 4. Same thing. 2, 3, and 4. Okay. Boop. Oh, also, just to make things easier to be read, I'm just gonna say when one iteration is done. There we go. So, first one, no problem at all. "23. Where is 23? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I was expecting your attention span to be here. Wait a second. Every time it starts at 0. So now attention span. Okay, I would like to know your attention span. Let's see. So pin, attention, start. Attention, start. Paste it over here. One to 13. Okay. 1 to 11. Okay. 1 to 9. Good. 1 to 7. Good. 1 to 5. Like over here, like 1, 2, 3, 4. What? Huh. Okay. So it would be helpful if I do this beforehand. So let me cut this thing. Okay. One to 5. So over here, this thing managed to become 81. So that's good. So 1, 2, 3, 4, 5. Perfect. So attention span should be over there. Now, at this point, you do not have this. Oh. 23. 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Your attention span is 1 to 5. How did you get 23? Attention. So we have the vector. So we have the vector and then target list, starting position, search direction, ending position. Meaning from a 1 to 5, search this. Alright, let's see what's wrong with search position. How did that went out of range? Wait. Oh Lord. Okay. And also, we're not hitting the end. So we haven't hit end. So ending position. Hopefully that works. Alright, let's clear this thing. Let's see. Let's run this thing. There we go. Alright, good. Okay, good. Keep on going. Okay. Okay. Well, at this point we know this. Range 3. I would say that's a small progress, I believe. From here, attention span is over here. Over here, you found no power, good. You found no multiplication or whatsoever, good. You did find an addition, which is there, good. Number 4, you don't find any functions, so that's good. So in this case, G3 should trigger you in this case. So let's see. This one. So in this case, we know that G3 is G3 is bigger than -1. So in this case, should do this. That explains it. Oh, wow, I was so... How in the world did they manage to get the others? I don't know. Alright, let's see. Whoop. There we go, and then we go just run. Okay. Whoop, 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 whoop. Syntax error. What went wrong? Attention span is 1 to 5. Yes. Let's take a look. Could be most likely this. So once we have this, how in the... Why? Why do I have +2? Recompile. Okay. Just run. Good, good. And then let's go. So the next attention span I'm expecting to get is here. So this thing, yep, just collapse to a 0. That should end up with an 18. 18 should collapse down to a single number. Perfect. The next attention span should be this one. This one should be a 1. Good. Next attention span should be that one. Next attention span should be this one. That should give you an 18. Next attention span should be this one, goes down to 18 again. Next attention span should be this one. Good, perfect. Next attention span should be this one, becoming itself. Oh. What do we have? Damn. Eight and 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not happy with this one. Okay, so if it can, I believe it's well, I believe it has nothing to do with that. So all of these are all negatives. There are a few times that we managed to catch that. The only difference is they are positive. Although all of them are that. Let's see. Else emergency halt. This is where things goes wrong. Oh wait, hey, I think I know how to fix this. Number is simple. Let's see, how do we implement that? Number is simple. So it has something to do with math, or in this case, it's the string one. This number, simple. Okay. Oh. Huh. It doesn't take care about negatives. Oh lord. Huh. Hmm. Huh. Okay. So one trick to do is the string has a single negative sign in front of it. If yes, remove it. It is acceptable. So we can just say test subject. You just say string test subject has whoop. So if test subject pass at 0 is just move this thing. Whoop. There we go. Should be good. That thing. If that 0 is a negative sign, and oh boy, I wonder. This thing is string math, string manip. Okay, trim will do the job. Yep, manip is there. Okay, good. So trim. So in this case, starting it would be, oh wait, no. Test subject pass. test subject pass. Starting from 1, ending at test subject pass. Length. Oh, function. Okay. -1. Test subject pass would become this. If there's no negative sign, it's okay as well. Now we will see if it's empty or not, like being naughty. For test subject pass, everything in there. Okay. Box string text subject pass. Okay. Box string, helper. Box string 1 until that. When this thing is a 0 and then this thing is still a 1. Okay. Like. So it's dealing with leading zeros, I suppose. Clean out leading zeros and backing zeros. Oh, okay. And check how many decimal points there are. None. A. Okay. Alright, good. So, is number simple? So in this case, back down over here. Is number simple? Oh wait, it gives an int. Okay. So technically speaking, not a number, int or float. -404. Syntax error. So yeah, we have that. Whoop. Okay. Okay, so now we know that if it gives a 1 or 2, then it's good. So another way to say if something is a valid number, then we can say if this thing is bigger than 0. If yes, then hooray. If no, Alright. So let's just go whoop. Let's do some cleaning. And then let's just run the whole thing again. Attention span should be over here now. And then this one. 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 And then hopefully this one. Eh. Uh-oh. Uh-oh. I doubt this is gonna work. It works? No way. This is gonna end up 21. I can't do math. I can't do math. 20 plus -1. Gura, I feel you now. Next. Yep. Oh no. Oh no. Yep, huge number. And we don't like that. This, well, apparently not a valid number, so I'm gonna stop there. You have to stop there. Not a valid number. So one way to fix it is, I have to say, this thing is actually way too huge. Is there any way that I can make 65 becomes something like a smaller number? 65 is still there. Oh. 65 is 81 minus 16. Which is this thing. Alright, alright. That's minus 48. Otherwise, that's too big. And it's out of bounds. Can't do that. Okay, 17 to the 19th power. I don't know if that is good enough. Let's go with 55. Because at this point, it will say he cannot interpret this as a number because I did not account this as a number. Like, what in the world? Whoop. There we go, emergency halt. In this case, you can treat this as a overflow. So whoop. Still no. How about we'll just minus 60? Hmm? Oh, come on. What happened to that? Don't tell. Oh, Lord. Oh, it's what? Oh, no. One, two, three, four. Uh. My brain cannot work with this many nestings. Hmm. Uh, go. Oh, it keeps on. There we go. There we go. That works. So that goes with that. And still this goes with that. Okay. So this one over here minus, let's say 60. Hopefully big enough. All right. Okay. We're looking good. So, yep. Now this one over here. Yep, whatever. Now your attention span should be over here. So for that one, you get that, which is correct. This one should get 3. This one you should get another 3. This one you should get an 8. Syntax error. Okay, let's take a look at this. Attention span 0. Attentions. 6. Your attention span should be here, which is totally off. Let's see. So 0, 1, 2, 3, 4, 5, 6. String segments, looking for this starting from 0, the right hand side until that thing minus 1. And then based on what is E. I almost forgot. Okay. One thing though, if we cannot find this, then it means that your attention span should be the whole thing. Otherwise, we should have that. Now, there we go. Okay. Oh boy, that was a lot of stuff. First attention span should be this one. And then the first thing that should happen is this thing. And then this thing. And then this thing. And then these two. And then these two. That gives you that. Next attention span should be this one. This one should give you a 0. This one should give you 18. Goes down to 18. This one goes to 1. Another 1. 18. This one goes to 18. Negative something. Goes down to negative something. So here's the whole attention span. It should go over here. And then this one should give you that. This one should give you this. This one should go down to that. And then to the power of that. This one should go down to that. And then attention span should now be here. This one should be 3. This one should be 3. Now this one. Okay, that's really odd. Because it is true that it's right there. Until 0. Oh. But that's strange. That does not make sense. When ending position is this, which is given by the param, then halt. Starting from this, going left until you hit that one, look for this. This one is an opening, and this one. Wait a second, let me go back to that. Because it feels like it has something to do with this. So, So when it was 0, this one says current index is still in range. Okay, so if, okay, let's say the search direction is left, and ending position, and then we have current index. If that's the case, then we can say current index minus minus. Else if search direction is R, then if current index is still smaller than ending position, then we can say current index plus plus. Alright, that looks pretty good. So let me cut that thing, paste it over here. I might just go whoop, and then whoop. That's good. Okay. So let's see. There we go. Okay. Huh. Just breaks the very first one. Wow. Is that where I changed from a 0 to a -1. Yeah. That's where it should be. There we go. Okay. So this is able to go for a few iterations. Okay, hopefully this thing catches up. Okay, good. Yes. Yes. Yeah. Hell yeah. Let's go. Let's go. Oh. Oh. Oh, that was so good. Oh. Hey, to be honest, I'm not drinking. I'm not a drinker or alcoholic or whatsoever, but I have tea whatsoever. That works as well. Cheers, everyone. Oh, Lord. Wow. That was the weirdest stuff. Cool. Wow. Like, that is really satisfying to watch, though. Cool. So in this case, let's turn this thing into a forward thing. So, see out, forward, see out. Console quick would be the thing, and this thing should be string in type. Should be something like a report. What? Okay, what makes it yellow again? Color a string. Let's see. So there is report, there is error, success, and prompt. Prompt is yellow. You know what? I'm going to say prompt. And then string. Or, you know what? I'm going to do it the flexible way. Shorthand, color text, yellow. In this case, pin, attention, start. And then basically just copy and paste this whole thing though. It's just we're gonna do it like whoop. And then there we go, and then let's go back to default. Okay. So over here, it will also say Boolean debug mode. So over here, we will say if debug mode, do the following. Green, there we go. For wall, string, shorthand, color tags. In this case, I'm gonna go with blue. And then we're gonna go with for wall, string again, shorthand, color tags, default. Okay, so we have that. Same thing happens here. For wall, string, shorthand, color tags, in this case it's another blue again, and then for wall, string, shorthand again, and then we'll go to color tags, and then it's default. Okay, cool. Now in the test, there should be one error. There we go. So in this case, it's true. This is a string expression, which is this whole thing. So come over here. Okay, and then we'll just hit clear, and then we'll just watch this thing run. That's how you make stuff blue, by the way, or green, whatsoever, whatever works. Works like a charm. Cool. Oh, you know what? It would be great if we make a calculator UI thingy. So yeah, we don't have to like come in over here and just start doing stuff or re-edit the whole thing. So that would be great. So this also means that we come over here. Okay, you know what? Let's try and find some expressions or whatsoever. Another string, exp2. So in this case, if we still remember, x is minus b plus sqrt of b squared minus 4ac. And then take this whole thing divided by 2a. We still remember that. Over here we do not have negatives. This time we have neg. There we go. SQRT, we can say SQRT is like neg as well. The only problem is we have to figure it out how to deal with that. Now, oh. This thing should be in red. Back to default. When we're all like printing the stuff, do we have pins? Oh yeah. Okay, good. So if I believe correctly, actually we have implemented a root approx. There we go. Try to guess the approximate root of a number. Is it like square root? Huh. Okay, seems like it deals with everything. So root approx. Okay. So what we can do here is let's see. So else if this thing is you know what? Let's do pow. Okay. Then we will need to like expect some stuff. Oh boy. Good question. Whew. Like okay, I'm going to be like really naughty over here and I just say wait a second. Technically speaking, we can actually use this. So also I forgot that. Hook. For more accuracy, you just say hook. There we go. That works. So I haven't tried anything like that yet. Okay, let's try math and then let's see. Root approx. The input. Let's go with a simple 8. Then the root. I want the third root. Iteration. Fine. I'm going for 15. Um. That does not look like it. How does it work? Let's see. So, box L, box R. For every iteration. Okay. Box L and box R. Huh. Okay. So input. Okay. Well, if that's the case, init box L double init box R. There we go. So it will say box L is init box L, meaning initial. So oh, init box R. There we go. Not quite sure if this will work, but it is experimental. Oh, what do we have? Oh yeah, I forgot. So we know the third root of 8 should be 2, so we know it's in between 0 and 4. That's pretty weird. Perfect. That's good. Okay. But what if I'll just go... Let's just go POW. Okay. And then I go 8. 1/3. Uh-oh, okay. Well, that's a problem there. We cannot exactly fully perfectly represent that. Ooh, close. Yeah, understandable. Oh. Okay. Okay. So, double, it seems like double is a better case over here. So, excuse me, we can use that. So, not a float anymore. We're going to deal with doubles. Excuse me. However, not exactly a big deal. It's just we need to change some of the, excuse me, stuff. First thing first, can we even... Oh wow. String to double. Let's go. Long double. No way. Cool. Alright. So if that's the case, we will be doing this. And then, yep, in this case, we'll just do POW. That will not be a float anymore. This will be a double. And then I'm waiting for the red one to comes in. Yep, there we go. Double. Float to string. You know what? Instead of saying float to string, why not say number to string? So in that case, it would be this. Number to string. In this case, we will need a template. So in this case, copy this thing. Wait. Hmm. Hmm. Put string result buffer clean and input. Oh, not a template. What do you mean by that? Hmm. Hey. Hmm. Okay. So, well, this is very versatile. Anything to string. So it falls under string. Convert. Yep, that works. So if I save it over here, waiting for the red one to come up. Yep, there we go. Bunch of them. First thing first, which is this. So in this case, we will just go for string convert anything to string. In this case, we're going to turn a double into a string. So in this case, it will be call res double. In this case, call res string will become this thing. This thing will be gone. There we go. Yep, there we go. Good. Next. STOD. Double. Call string, convert anything to string. Yep. That will work here as well. This thing, paste. This thing, double. OD and OD. There we go, there we go. That should work. That may take a while for it to kick in. There we go. Now for this one, yep, color as double. Turn it back to a double because at this point modulation can only deal with integers. So yeah, becomes a double. Turn it into a string. Yep, that works. color as float. So double. In this case, we're adding. Okay, so that. Okay, and then we'll just change this. Paste. Okay. In this case, change it to that. Change it to that. And then this will be a double. And then we'll just replace that. There we go. Now, same thing. Neck is over here. In this case, turn this thing into a double. Turn this thing into a double. Paste it over here. That should be good. So if we come back here, hopefully this does not break the stuff. So we have that. Cool. Okay. So, wow. Syntax error. Well, the first thing we definitely look at is 11. 15, 14, 13, 12, 11. What's wrong with that? Okay. I'm going to quickly look up ChatGPT on the other side just to see how to like really properly read a string as a double. Whoop, because I just guessed STOD, but that might not be the case. Still, ChatGPT gave me an STOD thing. Strange. And it just says syntax error. That's pretty odd. So I'm gonna just go cout forward math and see if something is a number, or it should be string instead. The math part of it is number simple. In this case, just be 2. It's a 1. 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So it has to look on this side and that side. What went wrong? Wait. There we go. Hey, good. So I believe this is the same thing. Smaller than or equal to 0. So, yep, that's the thing. So every time when that happens, then we know something is wrong. You know what, I'll just copy and paste throughout the whole thing. Paste it over here, and then I'll just paste it over here, and then paste it over here, and the same thing over there. This one, yep, goes for this one. Hope. And if, oh, then yep, it definitely needs to be bigger than that. So oh, okay, wrong thing. There we go. This whole thing again. There we go. So now, hopefully, we are dealing with doubles. Oh boy, the moment when we start dealing with doubles. Oh no. That looks disgusting. Yep, you end up with that whatever junk it is. Yuck. Okay, I just looked it up on ChatGPT and it says try and catch is available. So, use me. Okay, good. So if try and catch is available in C++11, then we should be good to go. So, okay, so over here I'm just going to say bool is number built-in double. So string test subject. So over here we are going to do this in this case we will say try this. We will say double. In this case, we will call this thing box. Is std of test subject. Now, if this thing runs well, we can say return true. Or when we catch it, oh boy, const invalid argument. Over here, ChatGPT gave me E, so I'm going to trust that for now. But whatever it says, I'm gonna return false. Catch the same thing again. This time it's out of range. Out of range. Another E for error, but I don't care what it is. I'm just gonna return false, and that's it. And if you somehow able to get outside over here, then something has gone wrong. So we go false. Okay, so gonna save this thing. Gonna come back here. So let's do the same thing over here. Math is number double, built-in double. So just gonna be simple as that. And then I'm gonna go 2.4 or 2.125 or -2. Yeah, all of those should be valid stuff. Now, the only thing that I hope it's valid is this kind of thing. So I'm gonna copy and paste that. So I'll just come over here, Control C. Now paste it over here, and then Control C, Control V. This time it's plussed. And then I'll just go Control C, Control V. This time I change the E to an A. Or just come over here, change this to N2A. Or I just come over here, just K, fine, kappa, whatever. Okay. So I'll just go whoop. It's going to be a lot of stuff. Huh. Okay. Strange. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you're telling me 2A is a number. Let me test. Okay, let me ask ChatGPT. Why is A accepted? Oh boy, ChatGPT got stuck over there. Like, ChatGPT was gonna be like, yo, dude, what? Hey, same over here. Well, by the meantime, since we all know these are all valid, okay, let's try that again. In this case, only the last one is that. So we don't need to test kappa anymore. But what about A2? Huh. Okay. So what ChatGPT gave me is, if STOD is managed to interpret something as a number before it hits something invalid, it is still acceptable. I personally do not like the sound of that. Okay, so if that is the case, I'm gonna try something. So I will go this, and then I'll just go 1.6 E plus 10 do the same thing again. One funny thing, I'm going to turn this thing into a string. And then I'll just take this whole thing again, put it inside an parameter, and I say std. And then Control C, Control V. Well, I'm gonna do that. And then see what comes out. Whoop. Ew. Okay. Oh, anyway. So now we are able to like interpret roots in this case. So now x becomes first we still need a negative b plus in this case square root. So technically speaking is we just take b to the 2 minus 4ac, take this whole thing and raise it to the 0.5 power. And then once we're done with this, we are just gonna divide this thing by 2a. So this is what we will be inserting into our expression interpreter. Well, of course, a few symbols are missing. In this case, the multiplication sign. So from the looks of it, that looks pretty good. Okay. So in this case, let's just go with oh boy, what would be a good number? Well, let's see. Let's see. So over here, we will just go hope neg. Let's go with 8. Okay. Plus open that thing. Plus open 8 to the power of 2 minus 4 multiplied by 2 multiplied by 3. 4 2 is 8, 8 3 24. So yup, that should be good enough. You should not end up with a negative number, I believe and hope. To the power of 0.5. And divided by 2a. 2 multiplied by a. A is 2 in this case. So hope. There we go. We just go clear. Just run. So over here, it evaluated. So I believe it sees this thing first. So first thing is 64. Nailed it. Next thing, I'm expecting this. Perfect. The next thing, I'm expecting that. Perfect. Next thing, I'm expecting this. The next thing, I'm expecting that. Ooh, that's not gonna look pretty. Ugh. Okay, cool. Uh-oh. Yeah, my bad. Next thing, this is gonna happen. However, this is not the thing that we wanted. So we'll end up 14 point something. And that's wrong. And then now we're just gonna turn this thing negative. No? Interesting. However, before that, let me fix it. So, whoop, whoop. So, let's see. The negative function. Well, it ended up as a syntax error. So, if this thing, pin 2, it should have been pin 1. Yep. There we go. Now we can test the whole thing again. Okay, so we go a couple of iterations. I forgot that. Okay, never mind. We can still test this. Well, that's new. Oh, wait, I think I know what's the problem now. Pin 2 and pin 1 should be the same. Let's see what happens. Emergency halt. Yep, it just looks at this thing, doesn't find anything, doesn't match any syntax, just say halt. Yep, that's a problem we have. So, we're just gonna come in here, and then, you know what? I'm going to be naughty, and I just do this for now. Okay? Just to see if that works. Still syntax error. Oh, is it because of the space? That would have been really strict. Wow, okay, that would have been really strict. That is really strict. A single space will kill you, just like Python. Alright, next. Let's see. So, the very first attention span should be this. Yep, there we go. Perfect. And then it should start collapsing. There you go. Works like a charm. Alright, you know what? Let's search online for some really weird expressions. Whoop. Weird math expressions. In this case, I'm doing it on a another machine. Let's see. Hold on a second. Huh. So far I haven't figured out any good ones yet. However, should be good. Well, it should be good when we start implementing trigonometry functions. So, neg is one of the functions. What else? Okay, one thing I'll definitely do over here is what I would call constant defining, meaning sometimes we will need specific constants, like for example pi or e, or sometimes the golden ratio. So yeah. So in this case, oh lord, or I don't know if that is like worth doing it. Okay. So, okay, I just looked it up in ChatGPT, and then because now I'm trying to implement the trigonometry functions. Now, the first thing first that comes into mind is definitely sine or sin, whatever works. And then from the looks of it, do we have CMath? Yes, we have. So that's definitely going in. Also, let's also include one thing. This is string convert. There we go. There we go. And then all of these are like really arithmetic to some extent, until over here it becomes linear algebra-ish, and then over here it becomes cryptographic, and here's something else. So in this case, that should be trigonometry. So in this case, a double trig sin, or no. Let's go with trig, and then dag, to red. So in this case, it's a float. And then another float. So we'll just go input. So we'll just say return something. So input degrees. So input, we do not want 360. Instead, we want 2 pi. So in this case, this one goes down. We don't want 180, we want pi. So in this case, it's 3.14159 something. 3.1415 9265 to the 89. Is it? Can't remember the rap song for the pi digits. Let me see. Pi. Boop. There we go. So 3.1415 and 9. 265 to the 35. 89. 7932. Okay. You know what? I would say that's good enough. So, you know what? This may sound stupid, but why not? Const. So if name is pi or name is pi or name is colon the Greek keyboard. There we go. Pi. There we go. Then we will return the following. Else if, okay, what else? If name is E. For now, I can only think of that. Return something. There we go. So 2.7 1828 again, 459 something. Oh, that's pretty interesting. 1828 again. Ha. 459. Well, that's pretty interesting. Or else if name is the golden ratio, we're just gonna return Well, for this one, we can actually do it in two ways. Either we can use the math expression stuff, or we can just whatever. Because golden ratio is actually you take 1, and then you plus or minus square root of 5. Then you take the whole thing divided by 2. That's the golden ratio. 1.6180339 8874, somewhere around there. Yeah, whatever will do. Else, we're just gonna return 0. That will do. In this case, we'll call in the Greek keyboard again. There we go. Huh. So in this case, I'm going to look for the constants and see if we can apply it. Some of the constants are somehow slightly stupid in a way. For example, the speed of light, in this case, is measured by using seconds and meters, where seconds and meters are actually based on the planet Earth. So that's pretty sad. What else? Okay, just looked it up. We have pi, imaginary unit, phi. I suppose that's the golden ratio. Gamma, not sure. Aleph null, that just means really big number. Feigenbaum constant? Huh, not quite sure what's that. Conway constant. Huh, definitely need to take a look at that. What else? Well, from the looks of it, not quite sure what else I can do with constants anymore. Okay. Well, I think that's pretty good enough for const. So, also over here, I might just go whoop. Well, there's also a high probability. Oh, I forgot to switch it back. I forgot to switch it back to English. There we go. Name. Now, there's a high probability someone would do that. There we go. Oh boy, got stuck being blue. Or what does it say? Expecting a dat. Oh, there we go, it works. Alright, cool. So over here, we're just gonna say, const with a K, just to make sure we don't want to clash with any name. Float, trig, rat, to, dag. Float input. So return input. This time we do not want pi. This time we want 180 degrees. So we have that. Alright, that looks pretty good. So if we come back down here, so over here it's neg. And then you can start doing trigonometry functions. So else if this thing says that. So so the fun part would be do we want to let this thing be a multi-input function? Because I was like thinking, because sine or whatever trig functions can actually take in inputs as long as there are numbers. We can either say, okay, treat this number as a rad or treat this number as an angle or degrees. Ooh. Huh. You know what? I'm going to do it the multi-input way. So over here, we need to move the pin around. Need to move pin around. So in this case, pin 1 is pin 0 plus 1, and then pin 2 is pin 0 plus 2. Now we just gonna like check. Whoop, this will do our checking and all that stuff. Paste it over here. So neg sin cos done. Okay. So this one over here, cos done. There we go. So if pin number 2 is not a number, then we'll just do that. if string segments, and then we say pin1 is not equal to sin, and we just copy and paste across the whole stuff. Cos done. And we also say syntax error. So first is that this needs to be sin, cos are done. And then, yep. Syntax error. Yep. And then if everything is set, then we can just do our crazy stuff. So in this case, we will turn this into our double, I believe. In this case, it will be B. String will be operand A, and then get it from string segments, pin1. Because we know by default in C++, if we did nothing to it, sin, cos, done will take their inputs as radians. So we need to do a little bit of conversion. So wait, this one should have been deg and red, because if it were not to be sin, cos, or done, it would have been here. Okay, so let's ask if string segments. Oh wait. Let's just say operand A. If operand A is deg, then we will say deg. If operand A is deg, then we will know operand B. Oh wait. For math trick deg to red operand B. Treat it as a float, and afterwards turn it into a double. Operand B will become that. Otherwise, if it were to be red, then let it stay there. Next, if string segment pin 0 is sin. Then we will say call res double. That will be okay. In this case, it's just sin, and then we'll just go operand B. Well, that looks pretty good. Copy the whole thing, paste it here, paste it here. So we just go else if there we go. This is cos, this is tan. Done. There we go. So there we go. So that goes our double, and now we have that. Okay, that looks pretty good. Uh-oh, wait. There we go. So we can actually do the same thing again. And then we'll just go paste it over here. Because now, instead of sin cos tan, we're now going to do it asin acos atan. Each meaning the inverse of it. So asin acos atan. Also, expecting one of them to be dag or rad. Otherwise, not gonna do it. So I want it as a dag or rad. So okay. So first thing first would be something like, okay, let's just convert it first. Let's just convert it first. So if that thing is asin acos atan, then there will be back here, and then if it's dag, because it's giving us value in terms of radiant. So over here we will need to say trig rad back to dag, and then if everything goes well, it should be good. Okay, this is something really weird. However, let's see how this thing goes. So, oh boy. I have to say, this is going to be the beefiest calculator I've ever made so far. string exp3. So in this case, first thing first, I'm going to test if something can be converted back and forward. So in this case, sin, treat this as a DAG, in this case, 30 degrees. Once you're done with it, technically speaking, this will give us 0.5. Once you're done with it, I want you to turn it back into degrees again. In this case, I should be expecting 30 again. So, hopefully nothing too fancy over here. Ooh, big oof. Big oof. Oh, wow, it didn't find? Huh. It says emergency halt, so I'm guessing here. It didn't found sin, cost, or done, but it's right there. Huh. Didn't picked up. Oh, that explains it. Yep. There we go. That's more like it. So, step 1, yep, it's doing it correctly. Treating this whole thing and turning it into 0.5. Now we have this. Now we have that. Did I got an extra space in front of it? Yes, I did. Yep. So, few iterations. Ooh. Okay. Something's off. Let's see. Definitely this part. So, okay. So first thing first, operand this, operand that. So if this is that, then first thing first, we'll just convert that back to this. That's why. Okay. Call res double. Call res double. Yep. Hopefully that should fix it. Okay, cool. So, oh. Beautiful. Beautiful. Yes. So, if we take a look at, if we still remember Pythagoras theorem, but in trigonometry form, something should looks like this. So in this case, we take sin, treat it as an angle 30. Okay. Take this whole thing, square it, plus cos that also 30, and then square it. At this point, we should able to get a 1 out of it if everything goes correctly. So in this case, let's just go number 4. Oh, I forgot a semicolon over there. Whoop. Alright. Boop. Just run. There we go. So now we have this. First evaluates that. Perfect. Next thing turns that into that. Next thing turn this into that. That does not look good. And then this one over here. Yep, really close to a 1. Really close to a 1. Almost perfect. Almost perfect. But because, you know, limited bits, IEEE stuff. Yep. Okay. Not bad. Not bad. Also, I want to test cos. That is expression number 3. Run it. Yep. 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 Good. So yeah, we have that. And I was like thinking, what if I'm just like being naughty? Like, what will happen if I just go what will happen? Let's see. It will definitely break. It will definitely break. I expect it. Emergency halt. It doesn't fit any what was it? Syntax. Yes. It doesn't fit any syntax. Plus, like, heck, if I just go this, it will go angry. It will go angry. Literally nothing. Okay. Okay. Wasn't expecting that, but alright, so we're pretty good with this. Alright, let's make this thing a usable program. So in this case, let's create a let's go copy, and then let's paste it. In this case, we will be renaming this to calculator. In this case, you know my style. Yep, that looks pretty good. Good. So technically speaking, okay, we do not need that, and we do not need that. So technically speaking, we do not need that. Okay. So this means that, hey, okay, this case string, I will say user input. For now, it's gonna be that. While user input is not exit, then we will say get line from cin to user input. Every time we do that, when we're ready to go, it will say cout forward experimental expression evaluate. In this case, we will be using our user input. That thing. Of course, afterwards we will add more quirky stuff so that the user can configure it however they like. So yeah. So let's go G++. Standard is C++ 11. In this case, we just go just run, and then we will say that. Oh, it didn't catch it up? Didn't catch up? Oh boy, it got stuck. Oh, there we go. It's a completely new file. There we go. So let's see. So now I'm just gonna say 1 plus 2 plus 3. Oh, oof. Okay. So we're going to build a safety system just to say if the string is completely empty, then we will just simply ignore it, like bruh. So so we will say if in string length is 0, then we'll just return with an empty string, or otherwise continue. Yep, nothing weird. and then we go just run. So let's go 1 plus 2 plus 3 plus 4 and then plus 5, and then just go way, and then go 4 times 5, and then you go 8 plus 4 multiplied by 56. And even if you like keep on going, like no matter. Syntax error. So that's interesting. So let's take a look at minus. Minus, it's over here. So whoop. Syntax error. Not quite sure how is that a syntax error, but number simple. You know what we're gonna do? It's like double built in now. You know what? Also, since plus and minus are similar now, we can actually combine them in a way just to make it cleaner. So if that is that, then built-in double, false, built-in double, false, then we'll say syntax error. Otherwise, turn them into numbers, and then if our pin 1 is a plus or a minus, so if this thing happens, then we will do that. So let's cut this thing, paste it over here, do the same. Oh lord, there we go. Copy and then paste, do the same thing. This time it's gonna be minus, and then whatever. So this whole thing is gone. And technically speaking, the same thing can be done over here as well. So let's go with double, built-in double. Oh, there we go, false. This one is also built-in double. Uh-oh. No? Oh, okay. This one should be false as well. Now, if any of those is false, then we know it's a syntax error. Otherwise, we'll just go if, and then we'll just go if this whole thing is multiply, then we will do this, Or otherwise, well, we just do the opposite. So go. There we go. That's division. There we go. And then turn that back to this. Okay. So technically speaking, we do not need this. Okay, from the looks of it, this looks pretty good. So if I press save again, okay, what was this like really weird stuff? Okay, anyway, I'm saying exit. 9? What do you mean by that? Okay. Oh. Okay, got it now. There we go. Just go with crazily huge numbers. There we go. And then this will definitely go nuts. Yep, they will not like that. Oh. And then just go. There we go. Perfect. Works like a charm now. And every time when I go exit. Perfect. Perfect. There we go. Nice. Nice. Splendid. Okay. That's great. That's great. Just in case, I'm gonna just go if user input exactly equals to help, or else whatever it is. So now we're just going to make a list of stuff which is available for the user to use, just to say, yeah. Okay, for in this case, let's go with string, and we'll go with shorthand color text. We go with yellow. And we'll go with that. Oh boy. Step one operations. In this case, we have power. Step 2 operations. In this case, it's multiplication, division, and modular. The next thing, step 3, operations. There we go. In this case, it will be plus and minus. Step 4, operations. In this case, we have neg, and then we have sin, cos, tan, asin, akos, atan. Oh wait, now I forgot this. There we go. And then we just copy and then paste, and then this thing should go back to default. So now it would be nice if the user doesn't know how to use some of the functions, we can teach them in the syntax error part. Like for example, over here, like, yep, there we go. We say cout forward. It's a string, shorthand, color text. That one should be red. Expected syntax. Sin, cos, tan, deg, red, and then angle. There we go. And then we'll just go with this. Paste it over here. Going back to default. Okay. You know, come to think of it, in this case, we'll just say at, and then we'll just say plus, and then plus. Well, technically speaking, we just need that. So every time when we come here, we just say, there we go, and then we just go with that. Perfect. In this case, we can do the same thing as well for the inverse. Hope. And then we can just say cout error message. And then we can do the same stuff again as well. Okay, the rest should be good. There we go, and then we just go with that. And then, okay, let's see. Oh, we'll just go with help, right? Hope. Perfect. So let's see. I'll just say I'm going to do that. So it just tells me expected syntax is that. So now I know syn DAC 30. That's 0.5. Okay. So one thing that we can definitely do is we'll just do boolean user debug. By default, let's go with false. So so just say debug. One thing we can definitely do is debug. That's for toggle debug mode. Exit calculator. So help, that's for debug. So user debug is not user debug, meaning we just flip it around, and then we will say something like debug mode set to user debug. Let's see. So over here, it's not that anymore. In this case, it's user debug. Yeah. Hey, so Do the same thing again. Just run. This time we'll just do help. So in this case, we have all of that stuff. Now what we can do is start doing whatever. Control C, Control V. That's everything we have. Whoop. As you can see, it just starts cleaning up. Huh. Interesting. So, division. Oh. Okay, I forgot that. There we go. Do the same thing again. This time, just make sure that it works. Come back over here. Copy the whole thing. Paste it. Ooh, did you guys saw that? That looks pretty cool. There we go. Perfect. Perfect. So now I'll just do what can I do? I don't know. Like, to be honest, I have no idea what I can do right now, but damn, this looks actually pretty cool. Like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. And then just watch it start collapsing. And then you just end up with the answer 36. Now, one thing I'll definitely do is to like decrease the number of end lines over here. So, where is it? End line, end line. That's a little bit too much. There we go. And then for, okay. So over here, we might want to like ask the user, hey, do you want to like start with help? So there we go. So that should do it. For those who use this for the first time. So now we just run. So over there, just ask help. Help. There we go. So that's everything we need to know. And then technically speaking, we can just watch it run this whole thing. So Control C, Control V. Right there. Boop. Oh boy. Yep. Oh, it starts to become ugly. Emergency halt. For what reason? Your attention span is over here. So... Okay. So in that case... This is where... That's why. Okay. There we go. Boop. And then we will just watch this whole thing go down. Like, whoop. There we go. And ends up with an answer. There we go. Perfect. So in this case, we'll just go it recognizes it, but it does not recognize the rest, which is expected. Nice. Okay. So yeah, we can just go 57 plus 38 plus that minus this, and then you just go, there you go, simple as that. So there we go, yay! And then when we're done, we're just gonna exit. Fabulous. Alright, cool. Now, one last thing before we end this stream. Oh boy, we've been streaming for 6 hours. So yeah, one more thing. That is to upload this thing onto our team's website. Now it's October 22nd, 0209. So now you know this is the newest stuff. This one over here, do the same thing. Version 2024 10 22 0209. Okay. Oh wait. Ooh. Huh. Okay. So in this case, let's just do some cleanup. We don't need this. You know what? I'm going to leave them in the comments section. So whoop, cut them. Paste them over here. So we all know that all of these are crazy stuff that can happen. Whoop, whoop. doop, doop. There we go. There we go. That's the help. That's the debug. Otherwise, do whatever we want. Oh wait. Another thing that I would like to have is the clear screen. Oh, that would be good. Clear the screen. In this case, we will be doing it a system call way. Well, over here, of course, I'm going to cheat and then ask ChatGPT how to do so, because I remember there is a way to do a system call. Okay, so just looked it up on ChatGPT. What we have, let's come over here. Oh, you know what? I'm gonna just copy and paste this whole thing. Debug, and then we'll just go clear. There we go. So in this case, what we need is if def win 32, we will call system CLS. Yep, I remember typing something that looks like this. Next thing is else. System, we just go clear. That's for Mac OS and other stuff. And we will go end if. There we go. Pretty neat. So if we just go over here, and then we just go just run, go help, whatsoever. If we just simply type clear, oh, look at that. So some funny numbers. Yep, there we go. Perfect. It's just okay, you know what? I'm going to make it more compact. So where is this string thingy? Or okay, you know what? I'm gonna go down here and then just before. Force print vector. So That has something to do with cout instead. Okay. Force print vector. There we go. Huh. Okay, I'm removing that. And I'm removing that. Oh. So doing that again. Let's go with this. Okay. Yeah, come to think about it, it's actually reasonable, so... In this case, you go neg something. Yep, that looks more compacted, so that's good. Alright, cool. Now we can actually zip this thing up. And then upload to the website. Okay. Whoop. 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 Okay, cool. So let's open this thing up. So I can actually for functions, in this case, we do not need the zip file, so we'll just delete that. No updates for no volts. Now we'll just like compress this thing, so compress to zip file. There we go. The next thing we need is calculator. In this case, compress to a zip file. There we go. So yeah, now we can upload this thing. Minimize. There we go. Let's see. In this case, we do not need the paint thingy. There we go. Here we are. Okay, let me adjust a few stuff since we do not need to exactly see everything. There we go. Perfect. Alright, so we will be heading to lakes.com. So we can upload our stuff right there. The only thing I do not like about Wix is it's in bright mode. In this case, let's go there. And that's the one. There we go. And then we'll just go edit site. Yep. There we go. It's loading. Of course, how long will it take though? Wow. Oh, that takes a long time. Well, one thing I can definitely close is code because we don't need that. So let me hit save on this. Nothing much else, and then we can just close this thing. Is it done? There are a few things missing. There we go. Okay. So we'll just go over here. And then we'll just go whoop. Now we'll just scroll down. So this thing. So we're just gonna change it. There we go. And then we'll just change the file. Creations. Let's go. CPP libraries. Yep, in this case we do not need this, so we'll just move this to trash. And then let's see. For functions and calculator, we just drag these two over here. Whoa! Just a few hundred bytes. Nice. So in this case, for function, should be this one. Okay. In this case, we can also duplicate an area over here. so that we can just let's change the background. So let's go image. First thing we'll definitely look into is calculator. Alright, what do we have? Some of them looks pretty dumb. Okay, fine. Let's go computer. What do we have? Now, some of these starts to look a little bit more interesting now. Okay, let's go with computer screens. Okay, so far the only one which fits the best is this, but eventually we will switch to something else. Well, fine, whatever works, man. Let's go with this. For now. So settings. Let's go with 10. Looks sweet. So edit text. Calculator. Use me. And there we go. In your console, accepts long and complex syntax and expressions. Oh wait, I forgot. One thing that we can definitely do is the factorial function. Well, I guess we can actually implement that. Just simply compile the file. If you are using G++, compile it with the following. G++ standard is C++11 minus O, whatever. In this case, just run whatever works, man. Or just say COBOL, whatever. Calculator. .cpp. Requires this. Yep. There we go. Now we have 3 files up over here. In this case, let's change the file to something correct, which in this case, it should be this one. So there we go. Hit published. There we go. So now it's online. So everyone can go there and download it. So yeah, that's good. So just a quick recap of what we have done today. We have created a console calculator. In order to, you can use that as a small little tool whatsoever. For example, if I just bring this thing up, in this case we just do an ls. We can see our just run is right over here because our calculators, it's right here. So if I just do just run, first it will do that, then it will do that, and of course I can just say clear. Perfect. So now, technically speaking, now I can start punching numbers. What, like 1 plus 2 plus 4 plus 8. Oh boy. Okay, I will need to adjust my screen a little bit. There we go, that's more like it. And then plus 16. So the moment when I type that, it starts collapsing and do its stuff. Do the same thing. There we go. Perfect. So if we just do help again, we can see all the available operations. So in this case, we have power, multiplication, division, modulation, plus, minus, negation, which is making a number negative, and then trigonometry functions, sin, cos, tan, and their inverses. And then afterwards, I'll definitely have factorial going on. Oh boy. So let's see, what else? We can just definitely go and, let's see, neg 8, okay, and now we just plus something like a power or something. Oh boy, we definitely need to come up with a whoop. Okay, I'm opening up a quick notepad over here. So we just go neg 8, and then we just go plus, and then we just go square root, but technically speaking, that is this thing. So what is in there? Let's go with 8 to the power of 2 minus 4 times 2 times 3. Okay, take this whole thing. Wait a second, let me give it a few spaces because we use that to separate the stuff. take that thing and divide it by 2 times a. Well, in this case, it's just 2, but I'm going to make it more exciting by saying 3. And then now we can just cut this thing and then come back over here, just go back over here and then just paste it over here. That's the entire expression. Pretty long, pretty scary. If everything goes right, this should calculate. So there goes our first iteration. There goes our second, third, and like every time when I just press enter, I can just see how we come up with that certain number. I made a mistake again. Well, as you can see, I was like trying to do the quadratic formula. However, I forgot to put the parentheses for the negative function, and eventually I get the wrong answer. So let's just paste this thing over here. So there we go. Paste it over here again. And gives you the answer for whatever that is. Yeah, so we have that. And also it can do trigonometry functions as well. So if I just go, I do sin 30. Well, for those who have been watching the stream, you definitely know this will not work. Why? The moment when I press that, we have this. So the expected syntax is when we type sin, cos, or tan, we need to tell it, hey, treat this thing as a degrees or a radian. So in this case, in our case, it would be sin deg 30. In this case, it will give us 0.5. So there we go. Of course, it works on both sides, so we can do asin. We want degrees from you. And what it's gonna be? We're gonna say it now. So sin deg 30. Or if you want to be trickier enough, let's do 60. Why not? So going through this thing, first we just interpret this thing into this thing, and then just remove the parentheses. Now it's just gonna take this whole thing and then just go boom, there we go. So there we go. Now we have that. This also means that we can also do some weird trigonometry stuff. So let's just go with sin deg. Let's go with 75. Pretty weird. Or maybe I should have done this. There we go. Sin deg 75. Take this whole thing to the second power. Sin. No. This time we do cos deg 75. Raise it, second power. Well, of course, Pythagoras theorem. This will give us 1. There we go. And then if the screen somehow gets a little bit dirty, like way too many stuff, like you want to clean it, we'll just go clear. Nice and clean. So yeah, just in case, for those who are watching this to the very end, thanks for watching. When will we be streaming again? I don't know. But yeah, anyway, this is all available for download. So just in case, if we go back here again, if we go to our team's website, it's loading. What you can do is you just go here. Oh, yeah. You just go to learn, which is this thing. Once you got there, you go to C++ libraries, and then you scroll down. Wait until it loads. There we go. Scroll down. Blah, 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 blah. There we go. That's what you need. Click it over here. You download it, and then just keep in mind it needs this. So what you're gonna need to do is afterwards, when you got this, extract it, put it in one folder, and then because it needs this as well, download this as well, extract it, put the thing inside with the same folder. So both files, which is this thing and this thing, needs to be in the same folder, and then you just compile it, and then it should run. Then you can have fun with the calculator and all that stuff. So yeah, in this case, if you're still watching this, thanks for watching, and I'll see you next time. Bye bye.